Yeah,
It's recording now? Yeah.
yeah. Okay, so today we're going to talk about our milestone 2, and this is what we've done from the previous milestone. We had just XG boost, and right now, and we had our memory separated. So we have managed to like integrate both of them together, and we have a run shown over here. I'm not running it right now because it takes time to run, so I'll just show our previous run. And here we can also see that previously with just XG boost, our system had a very low accuracy, but then we added K clustering and our accuracy increased by 60%. And we've also added SHAP, which Dio will talk about our results. Yeah, so this is our CSV file. I think Dio can take over.
Okay, so the reason why we integrate SHAP to our model is because individual XGBoost is a black box model, and we use SHAP, which explain which explain each feature's importance in the model, and basically SHAP calculates the it's like the how much each feature adds or subtracts from the model based prediction. And for a given transaction, for a given transaction here, SHAP tries all the combination of the features and to calculate the importance. And it is it's fast for our models because XGBoost is a decision tree structure, and it doesn't calculate all the branches, and it only works through the decision path in the tree, so it is fast and accurate. And here is our result for the SHAP. And because currently we are using the partial data set, and we still need to fix our data set, so it only shows the importance for each features, which will make sure the explanation is transparency, and that is SHAP part works. And then uh, Jason will introduce our isolated tree structure.
Yeah, sure. Let me share my screen. So this part is for our isolated forest model. Uh, our aim is to using like unsupervised learning to um, recognize a pattern for fraud. And yeah, we use isolated forest, and this is we have tried many parameters, and this one is, I think, are maybe not the greatest one, but optimized one. Parameters is estimators and max symbols, and random set is can be set to any. So um, yeah, and we can try to run it. But as uh, sorry, might have experiment. Maybe we can try this. Hmm. As the data is quite a bit large, so it takes some time. Mm. The merge data is around 1 GB for, yeah. Yeah, as it's running, I want to introduce the way we want like to improve some data, the method we use to uh, like improve the record rate. Like we uh, we define this function to uh, define this function to like find a maximum parameters that is should uh, for the for maximum record rate and yeah we just try different uh, try different grade and to test it and to see which parameter should be the confident one to increase like the record rate. Mm, okay, I don't know why this time takes so much time. Maybe I can see the previous results. I don't know. Yeah. So in previous result, we can see for the classification report, for the detect is zero means it's not a fraud, and for not fraud detect precision, it's 0.8, and the record rate is around 0.9. And for the fraud, its precision is like 0.12, and the record rate is quite a bit low. So yeah, it's common in this thing is common in like uh, unsupervised learning, and hopefully we can combine with XGBoost, and the record rate for fraud detection will be uh, much larger after combined models. Yeah, I think that's all for the report. And yeah, so sorry, this time the I think the data is too large. We take a lot of time waiting for this. Yeah, that's all for today's milestone 2, right? Yeah.
Yeah, it's milestone 2.